The average value is a question that comes up several times in seemingly unsuspecting areas. So it says it's one of the most important formulas we use this year, and that's true. The average value of a function on a closed interval, so meaning that in and of itself is kind of a weird concept. You think about a function as just being a curve on a closed interval, and an average value means an average y value. Sort of like a way of saying, over this interval, what's the average, weighted average of all the different y values? And there are an infinite number of y values. So the way that we're going to do this is actually by saying visually, and I like this, let's take the area of this curve, and I want to find the height of the rectangle of equal width that would have the same area as the area of that curve itself. This height is going to be the average value by what we consider to be an average value. So what I'm doing is I'm taking this, which is the area under the curve, and I'm dividing it by b minus a, which is the width. So if I take area, which is in and of itself is a length times a width, and I divide it by width, I get a height. So every time that you see the word average in a problem related to integration and average value, you should be thinking of this formula. In the formula itself, whatever function you're trying to find the average value of is your f of x. And you're often asked to find the average value of a function on a time interval, meaning over a given period of time, where time is the variable between your two extremes, what is the average value? For instance, this is a formula for average velocity. The average velocity on a particular time is the integral of the velocity curve on that closed interval divided by the width. In other words, it's an area divided by a width. So the more you think about the integration of a curve as being an area, and the 1 over b minus a as multiplying by a width, the better off you're going to be. I'm going to write that one more time off to the side here, that if I think of 1 over b minus a as dividing by a width, and I'm multiplying that by an integral from a to b of a function, which in and of itself is an area, then area times 1 over width, which is really what 1 over b minus a is equal to a height. And that's the height of the rectangle of equal area. And that height is a y value. That's an average value of a function. So we're going to do a couple of examples and practice this. The average value of this function on the interval from 1 to 3. So if I do 1 over 3 minus 1 times the integral from 1 to 3 of 4 times x squared plus 1 over x squared dx. Okay, so the easiest way to kind of deal with this is to take this 4, bring it out as a constant multiplier, and that's 4 divided by 2, so that would be 2 times the integral from 1 to 3, and then I'm just going to divide the x squared into the numerator to get 1 plus x to the negative 2 dx. Then the integral of this, or the antiderivative, would be 2 times x plus, this actually minus x to the negative 2, and that would be evaluated from 1 to 3. So we get 2 times 3 minus 3 to the negative 1, then minus 1 to the negative 1, which is just 1. So I get 2 times 3 minus a third, or 2 times 8 thirds, or 16 thirds. So that's what's considered to be the average value of the function, and it is a value. You end up with a single number, 16 thirds. Okay, next question asks for the average velocity on a closed interval. The average velocity, this is a little bit of a trick question. You have to be careful about this, because the average velocity on the interval for the position function is something that's kind of relatively easy to consider, given that I have a position function, and if I just try to say, okay, average velocity of this should just be s of 3 minus s of negative 3 over 3 minus a negative 3. That's final position. This is just a change in position over a change in time. In other words, a change in position over change in time should be equal to a velocity. Now, given this, this sort of sets up a very intriguing little thing right here, that this is S of B minus S of A over B minus A. And another way to do the same thing would have been to say, here's the position function. So I know that the velocity function is equal to 12t squared minus 6t plus 2, the derivative of position. And so if I do 1 over b minus a times the integral of the velocity function from a to b with respect to t, I would get, let's see, I'd get 1 over 3 minus a negative 3 times, well, the integral of velocity is position. It is s of t, and I would just get s of b minus s of a, which is what this is. So whichever way you do it, you're going to get the same thing. Now, we already have the position function, so I might as well just plug these values in. 4 times t cubed. Let's have a little fun with this and do this with synthetic division. So I'm going to take the coefficients of 4, negative 3, 2, and negative 1, and to substitute 3 in, I'm going to do the synthetic division algorithm. 4 times 3 is 12, plus negative 3 is 9, then 27 plus 2 is 29, then 3 times 29 is 87, plus 1 is 86. So I would get S of 3 would be 86, minus, then let's do negative 3. So this would be negative 12, negative 15, positive 45, positive 47. 47 times 3 is 50 times 3 minus 9, so that would be 141. Negative 141 minus 1 is negative 142. So 86 minus negative 142 all over 3 minus negative 3 is 6. So I get 86 plus 142 over 6, or 228 over 6, which would be 114 over 3, which would be the same as 38. And you want the units, so average velocity, this would be 38 feet per second. This next question is about traffic flow, which rate at which cars pass through a function is measured in cars per minute. The flow itself is modeled by this function f right here, and it wants the average value of the traffic flow over the time interval 10 to 15. So this is 1 over 15 minus 10 times the integral from 10 to 15 of 82 plus 4 times the sine of t over 2 dt. So that's the setup. A lot of times you're going to see these as calculator questions, and you'll be able to quickly plug them in. We're going to go ahead and do this by hand. 1/5 times the integral of 82 would just be 82t, plus the integral of sine is negative cosine, so I'd end up with minus 4 times the cosine of t over 2. And by chain rule, I'd have to, if I was taking a derivative, I'd multiply by 2, by 1/2. So this is going to be dividing by 1/2. So this would be end up being 8 cosine of t over 2. You can prove that by doing a u substitution, where u is equal to t over 2. But I think a simpler way to think about it is just to take a derivative of this, where we would get positive 8 sine of t over 2 times 1/2 to bring us back to the 4 sine of t over 2. And this would be evaluated from 10 to 15. Let's just try to get as far as we can before we're going to say we just would want a calculator for this. So 1/2 times 82 times 15 minus 8 times the cosine of 15 halves. So right away, that's nothing that we could simplify by hand. But then we have minus 82 times 10, and then that would be minus 8 times the cosine of 5. So I would get 1/5. I can actually simplify this. 82 times 15 minus 82 times 10. It's 15 82s minus 10 82s gives me 5 82s. And 5 82s is 410, so that gives me 410. And I have minus 8 times the cosine of 15 halves, and plus 8 times the cosine of 5. And at that point, we'll go ahead and just enter that into a calculator. And whatever value you get, this would be in units of cars per minute because it's an average value. It's basically saying that over this time interval, whatever number you come up with for this expression here, that many cars per minute is sort of the average of what your flow is looking like. Many times you'll also have a question, a free response question, say to just set it up rather than evaluate it. So you would stop right here and it would just want the setup. That's pretty common. Okay, next, let f be the function that's defined for all real numbers x and has the property that f prime of x is equal to this and f of 1 is equal to 1. And wants the average value of f prime of x and the average value of f of x on this. So the average value of f prime, so I'm going to say average f prime of x is, let's see, well, we want to do, it says on 0 to 1, so I want to do 1 over 1 minus 0 times the integral from 0 to 1 of f prime of x dx. And that's just doing, okay, so 1 over 1 minus 0 is 1. The integral of the f prime, according to this, would be, that'd be x cubed plus x squared plus x evaluated from 0 to 1, and that would just be 3. But if I wanted to do the average f, then I actually have to figure out what is f. So let's do another little step right here where I integrate this and say that I know that f of x would equal x cubed plus x squared plus x plus a constant. And then I'm going to use the fact that f of 1 is 1, so I get 1 is equal to 1 plus 1 plus 1 plus c, or c would be equal to negative 2. So I now know that c is negative 2, and my average value, my average f of x value would be 1 over 1 minus 0 times the integral from 0 to 1 of f of x. So that would be the integral of the function f of x. And if I can sneak it in here, I know f of x is equal to x cubed plus x squared plus x minus 2 because we figured out what the c value is. So let's see, I need to put f of x dx. So this is equal to, let's integrate it, x to the 4th over 4 plus x cubed over 3 plus x squared over 2 minus 2x, and that would be evaluated from 0 to 1. So this would give me a 4th plus a 3rd plus a half minus 2. Let's keep that going. This would be 3/12 minus 4/12 plus 6/12 minus 24/12. So negative 1, 5, and 5 minus 24, this would be negative 19/12. Okay, number 5, it gives me a second derivative, and it says that the graph of f is tangent to this line at x equals 0, and it wants the average value on the closed interval. Well, the graph of x is tangent to the line, tangent right here at x equals 0, which is basically means that if I take this and solve it for y, I get y is equal to 3x minus 2, which means that at x equals 0, the slope of the tangent line, in other words, f prime of 0, would be equal to 3. Read the problem very carefully to see that that's what this is saying. It's saying that f prime of 0 is 3. So given that, I know that at x equals 0, f prime of 0 is 3. And I also know that at x equals 0, f of 0 is equal to negative 2. Because if it's crossing, if it's tangent at that line, that means that that line crosses through the point x equals 0, so it'd have the same y value. So we're using these two pieces of information to work our way backwards from the second derivative, given as 6x plus 8, to f prime of x, which is equal to 3x squared plus 8x plus a constant. So then I'm going to substitute this ordered pair in and get 3 is equal to c. So I know then that f prime of x is equal to 3x squared plus 8x plus 3, which means that f of x would have to be equal to x cubed plus 4x squared plus 3x plus another constant, which I'm just going to call C1. If I plug in 0, -2, I get -2 is equal to C1. So then I know that f of x was equal to x cubed plus 4x squared plus 3x minus 2. And my average value would then be 1 over 1 minus a -1 times the integral from -1 to 1 of that x cubed plus 4x squared plus 3x minus 2 dx. And then we can go ahead and evaluate that. So this is 1 over 2 times x to the 4th over 4 plus 4x cubed over 3 minus 3x squared over 2 minus 2x, and that's evaluated from -1 to 1. And it may seem like this is a little bit much to do by hand, but this is not uncommon for them to have to do lots of fraction work like this. So let's just practice this. 1/2 times, this would be 1/4 plus 4/3 minus 3/2 minus 2. That's the first part, and then you'd subtract and plug -1 in, minus 1/4. This would be minus 4/3 minus 3/2, and then plus 2. And you have to keep track of what stuff now cancels. The 1/4 go away. You get 1/2 times the 4/3 becomes an 8/3. The 3/2 go away because those are opposites, and then minus 4. So 1/2 times, this would be 8 minus 12, or -4/3. You'd end up with -2/3. Okay. Number 6 says let f be this function where p is an arbitrary constant. Doesn't matter. It wants the value of p so that the average value is 1. So I'm going to say 1 is equal to 1 over 2 minus -1 times the integral from -1 to 2 of x cubed minus 6x squared plus p dx. So I'd get 1 is equal to 1/3 times x to the 4th over 4 minus, this would be a 6x cubed over 3, so 2x cubed plus px. Remember, p is a constant. That's evaluated from -1 to 2. So if I multiply both sides by 3, I get 3 equals, and then I'm going to plug 2 in. So I get 16/4, 4, minus, then 2 cubed is 18, so 8 times 2 is 16, then plus 2p minus, and I have 1/4. This would be plus 2, and then minus p. So if I simplify a little bit, I get 3 is equal to, this would be -12 plus 2p minus 1/4 minus 2 plus p, or 3 is equal to, I'd have -14 minus 1/4 plus 3p. I'm going to multiply both sides by a 4. So that would give me 12 is equal to negative, let's see, this times 4 would be, I want to make sure I get this right, 56. So -56 minus 1 plus 12p, or let's see, that would be -57. So 69 is equal to 12p, or p is equal to 69/12. If I divide both by 3, I'd get 23/4. And then 7 says the position is given by this function and wants the average velocity over the time interval. Again, average velocity is not average position. So this is just s of 4 minus s of 1 over 4 minus 1. That's an easy one to think about and do. So if I can just plug 4 in, 4 to the 4th is, let's just quickly go and do 4 to the 4th. That is 2 squared to the 4th, or 2 to the 8th, or 256. So I would get 256 plus 8 plus 10, and then minus 3/4 minus 2 minus 10 all over 3. So if I combine terms, get rid of those 10s, I'd have 256 plus 6, so that's 262 minus 3/4 over 3. Let's multiply both the numerator and denominator by 4. So 264 times 4 would be 54, then 1088 minus 3 over 12, or 1085 over 12. And just check that 1085 is not divisible by 3, and it's not.